Hello, I'm Peter Hand. I'm going to be talking to you about using Limn, the flowsheet processor, to simulate a DMS circuit. Obviously, there's only some of the key features I'll be able to show you while I'm doing this. I've just put together a basic flowsheet. I've normally put 500 tons an hour, desaliming screen, fines tank to underflow, classifying cyclone overflow, dewatering screen and the thickener. And then on the dense medium portion, we have a cyclone, and we'll know how many we actually need just now. Drain and rinse screens with a static panel on the float section. CM tank and dilute tank. It is the lines for clarity is white, water is in blue, black is for basically solids, feeds. Red is for correct medium, so it's a good visual guide to see if you've got things going to the correct places. Green is dilute, dash green is effluents from things like MagSep. So that's the approach. And the whole point with Limn is to be able to set it up using constraint controllers and everything else to be able to fully balance the circuit. And at the same time, all the equipment is being sized, so we can tell the number of modules we need and that sort of thing. Okay, so this is some of the data. The more data you've got, obviously, the better, in the sense that we have washability per size. So you can see the plus 50 mil fraction up here, and then the washability per size fraction. And where we haven't got sufficient, so in other words, there we got the 12.5 by 20, we split that into two, and we've got the same washabilities and the same on the fines as well. So we use as much information as we have, and we have a particle size distribution on the right-hand side. And with all of that, we have the CV, inherent moisture, ash, volatiles, and everything else. This is the dense medium cyclone page, the actual model. So the way Limn works is if you click onto a particular piece of kit, it will take you to that page. Anything white and blue is sort of additions, so is inputs. So here I've asked for an 800 mil cyclone. I've got drop-down boxes for things like inlet diameters, vortex finders, and that sort of thing. So you can tell, we can manipulate the geometry. We have a medium density, which then turns into a cut point density based on various transpositions, which a lot of it after Chris Wood, who's got a dense medium cyclone manual. I'll show you some of the code on there just now. So the sizing of the cyclone, what we've looked at, we got 800 mil cyclone here. And based on about 1.7 cyclones, so if we round it up to the nearest two. On the right-hand side, we have all the medium flows. So the pulp flows are the amount of magnetite we need, the water we need, and so it goes, and the pressures, all of those sort of automatically calculated. Within Limn, the code is open, so you can look up, and in fact, you need to look up what's going on. So, for example, in here, we have the DMC feed capacity, taken mostly from Multotec information. So the less than 850 mil cyclones and then greater than 850. And at the bottom here, we've got a spigot capacity. A lot of that is based on Chris Wood's work. So all of these things are calculated. So as we have the feed, we can, and the head pressure changes, and we can change the spigot diameter. It would say how the loading of that spigot as we go. And even better with this is the fact you can add your own code. I'm not much of a programmer myself, but I can make my way, and I can certainly take examples and use those to be able to expand the things I need to do in Limn. Everything inside Limn, obviously, when you're normally working in Excel, it's actually difficult to start getting into the absolute detail of things like the with screen efficiencies and cyclone efficiencies. So in a lot of time we actually ignore them. But in the case of Limn, we are working on top of Excel, but we don't have any problems with circular errors. So we can actually assign efficiencies that we expect to screens. So for example, if I was working on a dry screen, that RF, which is a misplacement of fines to the overflow, would be fairly high. If I'm working on a desliming screen with plenty of water, that RF would be an awful lot lower. So I can actually start working out exactly how my screen should work. And also depending on how I select my cyclones, I can, I still believe in breakout points. So we can kind of apply EPM for different sizes of cyclones. This portion is actually sizing drain and rinse screens and a desliming screen. So on the left, we have a desliming screen. Here, in this particular scenario, we have a 5 meter width requirement. We happen to have two 800 mil cyclones. So if I make it 2 modules, it will round that up to the nearest basically foot width. So it's a 2.7 meters. And on the right-hand side, we have a drain and rinse. It calculates the amount of fresh water, amount of effluent water that we need. And we also, because it seems like we need 2 modules, so we have two 800 mil cyclones, we have 2 desliming screens. Therefore, if we've got 2 modules on the drain and rinse screens, then we'll be looking at, it's 3.7 divided by 2. And I'm just trying to find my screen width. Standard screen width is 2, which should be actually at 2.1. We can also calculate out the adhering medium that goes to the rinse section. So by having all the different calculations, a lot of it is actually based on the old DSM handbook, which I know has been superseded in a lot of ways, but in a lot of ways, a lot of it is still very valid. So DSM handbook is actually being used. Okay, a lot of things have been added in by myself and in fact lots of other users. So for example, we can size things like magseps based on the amount of magnetite we have in circuit and the amount of slurry flow rate to each individual magsep. So once again, we're looking at we need 2 modules, so therefore we would need 2 magseps. So if we use a magsep of about 1.25 meter width, then we can install 1 magsep per circuit. And the mixing box dimensions, that's what we can, the dimensions are easy to calculate. And we can also, in this case, I just look up pump curves, but it does, I am able to, it will give me the total volumes. Anything black on grey, by the way, is calculated for you. So we can put in the number of pumps we need. The tank is also being sized on this page. We can make some sort of pass at the amount of the head and the pressure into the cyclone, obviously 9D, and whatever losses we have. We can therefore select a pump, in this case an 8.6, 2 8.6s, 1 per circuit. And we know the absorb power is 75 kilowatt, and we go 1 above, and there's a drop down there that you can't see on this. So we select a 110 kilowatt motor. So we also know that the current draw is 142 amps, and we also have a drop down to select a pipe, so that we can get our pipe velocity, the velocity in the pipe as in the correct range, 2 to 3 meters a second. And so it goes also with the correct medium pump. And this is just it's almost like an easy way of being able to size the pumps, but there is some manual addition to it. We also have controllers all over the place. In this case, I've only shown 3. We got the fines tank. I want that to be basically nominally 10% solids into the fines tank, because I'll be feeding a classified cyclone after that. I also have a magsep underflow, which I need to distribute correctly. And I also want to be able to calculate out to control my CB. So based on the feed data that I showed in the second slide, that if let's say we want a 27 CV and my circuit is capable of between 1.3 and 1.8 density, I've asked it to go change my density until I can get to the exact quality. In this case, it happens to be 1.625 density, which is not necessarily the cut point. The cut point might be slightly higher. We can also use the scenario solver that's built into Limn to be able to do multiple solutions. So in this case, what I've asked to do is go from 1.3 to 1.8 in steps of 0.05. The cut point is, the equivalent cut point is actually shown as well. And I just wash the coal, and it will then, at different densities, and it will then spit out, right, I've got 26% yield, and that gives me 28.8 CV, just under 10 ash, and so it goes. What I've also asked it to do is to calculate out how many cyclones do I need? Does anything change? Obviously, cyclones shouldn't change too much depending on feed. And also, but if I was in a low yielding area, my spigot constraint kicked in, then it would tell me I would need more cyclones. In this case, I don't particularly need to. It can also give me my envelopes of performance of my float screen, my sink screens, and obviously my desliming screen, which shouldn't change either. But I can apply this to every piece of kit that's been sized in circuit. So things like mag seps, tank sizes, etc., I can use. And this, I've set it up so I can automatically generate my main equipment list. So at the top, I've got the CM tank of what's the capacity I've selected. You notice everything's by the twos. I've got 7 classifying cyclones, but I wasn't too worried about that because it's not part of the dense medium circuit. 2 desliming screens, 2 cyclones, 800 mil each. The 2 mag seps, 2 mixing boxes, only 1 static panel, just on the floats only. The thickener that associated with this would be about 26 meters. 2 float screens, once again, 2 meters, should be 2.1. And my sink screen, I've got 2 by 0.9 meter width screens. I could also calculate, I've put in, because I put my pumps in and my other gear, I can then come up with a nominal power requirement for this plant as well. Okay, and then the practical washabilities are similar to what I showed before with the scenario solver. When I call it practical washabilities, we all know what to be able to read off a densimetric curve. But in this case, we've got the screen capacities built in. We've got the screen efficiencies built in. We've got the dense medium cyclone efficiencies built in. So when I'm saying practical washabilities, it's what should actually come out of this this plant. So in this case, we've got at the bottom, we've got the quality. So if we're looking for particular products, and obviously this is an air dry CV, but if I wanted to calculate out my net CV as received, and then develop I've got a product page where I can actually calculate out the revenue for each individual net CV as received. So then we can actually calculate out the revenue from the circuit based on what yield we're getting, what revenue we get at each particular yield. And at the top, if we want to know the envelope of performance of this plant, I can actually look to see when will I run out of screen width capacity or whatever it happens to be. So I could put cyclones on there or whatever, but that I can develop the whole circuit and know the envelope of performance of that circuit. Okay, that's pretty much what I need to say for this section. So has anybody any questions?